So day before yesterday, we started with the RC circuits for frequency domain analysis, right? So the next obvious topic is for RLC circuits. So as you observe in this circuit, we have a resistor R, inductor L, as well as a capacitor C. So these are all questions based on RLC circuits. So the question goes like this, very simple. The switch is opened at t equal to 0. Determine V of t for t greater than 0, right? So at the first glance, you should come to know that we have to use KCL. Obviously, you can use KVL also, but it will be very tedious, right? So as usual, what we do at t equal to 0 minus, that is just before switching, what will happen? The switch is closed. So we'll write at t equal to 0 minus switch is closed, right? So what will happen when the switch is closed? So and we'll assume that steady state is attained, right? So resistor will be as it is. What will happen to the inductor? Inductor will act as short circuit, right? So, and this will be open circuit. So I hope this is clear by now why they act as open and closed circuit. So this is V of 0 minus plus minus. So this is voltage across capacitors. So we can call it as VC of 0 minus. Right? But it is given, so we cannot change it. Right? So this is 0.5 ohms. This is 2 amperes. So what will happen, since this is a short, the current through inductor will be what? 0. So IL of 0 minus is 0 amperes. And V of 0 minus is also 0 volts, right? And since current through inductor does not change instantaneously and voltage across capacitor does not change instantaneously, therefore IL of 0 plus equal to 0 amperes. Again, you have to mention this in the exam. And V of 0 plus equal to 0 volts, right? So next, what will we say? We'll draw the circuit at t greater than 0. So at t greater than 0, so what will happen? We have a current source of 2 ampere, so 2 into constant, so Laplace transform of 1 is 1 by s. So we'll go in Laplace domain or s domain. So this will become 2 by s, right? So again, now the switch is open, right? So this will not be there. So 0.5 ohms, 0.5 ampere and 0.5 farad, and all currents and voltages are 0, so I can directly draw them. And a capacitor, right? And this will become what? V of s, right? So this is 0.5, 1 by 0.5 s, 1 by cs. This will be ls, so 0.5 s, and this is 0.5 ohms, and this is 2 by s, right? So what will we do? We'll apply KCL. So apply KCL. So again, this is the voltage Vs over the entire line. So what will we say? Assume all currents as outgoing, right? So all currents are outgoing. So this is in opposite direction. So minus 2 by s, which I can write as equal to 2 by s. So I am writing it directly, skipping one step. So what will I have? V of s upon 0.5 plus V of s upon 0.5 s. I don't have space, so I'll write here. So V of s upon 1 upon 0.5 s, right? Here plus, right? So if you solve this, what will you get? So 1 upon 0.5, 1 upon 0.5 is 2. So this will be 0.5, and this will become s, V of s plus 2 V of s plus again 2 by s V of s equal to 2 by s, right? So what will we do further? We will just simplify and try to find V of s. So what will be V of s then? So it will be 0.5 s plus 2 plus 2 by s equal to 2 by s, right? So I'll write here. So therefore, what will be V by s? It will be 2 upon s upon 0.5 s plus 2 plus 2 by s. So take that. So this s will get multiplied here. So 2 upon 0.5 s square plus 2s plus 2, right? So again, what we want? Coefficient to be 1. So what will I have to do? So this is half. So multiply and divide by 2. So therefore V of s is 4 upon s square plus 4s plus 4. So what is this? S plus 2 the whole square. So therefore v of s is 4 upon s plus 2 the whole square. Right? So next what will you do? Taking inverse Laplace transform. This step is very important. You have to write that you are taking inverse Laplace transform. Right? So now what is the Laplace transform of t? It is 1 by s square if you remember. Right? So instead of 4 is a constant, so you don't worry about that. So what will be s plus 2? T into e raised to minus 2t. So therefore I am writing the final answer here. 4 is constant, so as it is. So this will be t into e raised to minus 2t. Right? Volts. So this is our final answer. Right? So I am using the property here, shifting property. Okay. So this is how we can solve the first sum. So let's proceed to the next sum. So it is given in the network, switch is closed and steady state is attained. At t equal to 0, switch is open. Determine current through the inductor. Right. So again at t equal to 0 minus, what is happening here? The switch is closed. Right. So how will the circuit look like? So capacitor will act as open circuit, inductor will again be short circuit. So this is 2.5 ohms, this is 5 volts. So what will be the voltage across capacitor? So this is Vc of 0 minus, this is IL of 0 minus, right? So current will flow through the inductor and there will be this drop of 5 volts also, right? So what will be IL of 0 minus? IL of 0 minus will be 5 upon 2.5. So it will be 2.5 to the, so 2 ampere. So what will be Vc of 0 minus? So next what will be voltage across capacitor, since it is connected across a short, since, right? So voltage here is 0, so obviously this has to be 0. Voltage is same in parallel, so this is 0 volts. Then again we'll say current through capacitor does not change, voltage across capacitor does not change instantaneously, and current through inductor does not change instantaneously. Therefore IL of 0 plus is 0, Vc of 0 plus is 0 volts, right? So then what will we do? As usual, for t greater than 0 we'll draw. So at t greater than 0, so what will happen? So switch is open now, so this source goes away, this 2.5 ohms goes away, so I only have a capacitor and a inductor. So we have seen in the equivalent circuit that if you have a inductor with a initial condition current, what will we do? We'll draw a voltage source in series and value will be what? I of 0, right? So how will it look like? So this will be the capacitor, inductor, and this will be the voltage. So 1 by Cs, remember, in Laplace domain. So 1 upon 200 into 10 raised to minus 6 s. 200 into 10 raised to minus 6 s. Capacitor is 0.5, so L into S. So 0.5 into S, right? Then this is what? I of 0. What is the formula? L into I of 0 for voltage source. So L is 0.5 and I of 0 is 2. So 0.5 into 2 is 1. So this is 1 volts, right? And the current I of t will become what? I of S, right? And we saw that the current is going downwards, so this will be minus up and plus downwards, right? So then what will we do? We'll apply KVL. So let's say I'm starting from here, so I'll come here, right? So what will be the current? It will be, I'm writing the voltage equation, right? Okay, anyways I'm in Laplace domain, so I don't have to worry. So it will be, this is the impedance. So 1 upon 200 into 10 raised to minus 6 s into I of s, and it will be minus. I am going in this direction. Current is plus here and minus here. I have to lower potential. Minus 0.5 s I of s plus 1 equal to 0. So therefore I'll take I of s here because it will become positive. So I of s into 0.5 s plus this will be what? 2 into 10 raised to minus 4. So 10 raised to 4 upon 2. right? So it will be 10 raised to 4 means 5000 upon s plus 5000 upon s equal to 1. So therefore I of s equal to, this will be 0.5 s square plus 5000, right? So next what will we do? 0.5 s plus 5000, just a minute, 0.5 into s square plus 5000 upon s, right? I am taking LCM. So therefore I of s equal to s upon 0.5 s square plus 5000. Again I want coefficient to be 1 for s square, so I'll multiply by 2, so 2 upon s square plus 10,000. Then take inverse Laplace transform. So I of t will be, so this is of the form s upon s square plus omega square. So cos, so 2 cos omega square is 100. Omega is 100 in fact. So 2 cos 100 t for t greater than 0. Unit is ampere. Right? So these are quite simple sums which you can solve. Okay. And I have taken all the sums in the book for this topic, so you don't have to worry. So next, in the network, switch is open. Steady state achieved before t equal to 0. So find I of t. So as usual, the same type of sum. So at t equal to 0 minus, so what will happen? So switch will be closed. So again this is open circuit. So this will be short circuit. So this is 1 ohms. This is 1 volts. So this will be Vc of 0 minus. This will be IL of 0 minus. Right? So current will flow. What will be the current? 1 ampere, 1 upon 1. What will be the voltage? It will be 1 volt. Yes. Right? So again, current through inductor does not change instantaneously. Voltage across capacitor does not change instantaneously. So therefore, IL of 0 plus equal to 1 ampere. Vc of 0 plus equal to 0 volts. Right? So next, at t greater than 0, what will happen? This will become 1 by s. Voltage source 1 into 1 again. Laplace transform of 1 is 1 by s. Switch will be open. So we don't have to worry. So this is neglected. So no, we need to worry about 1 or 1 by s. So capacitor, we have a voltage source now. So what will this be? V of 0 by s. So 1 by s, I will have a voltage source. Right? Then here it will be 0.5 into s. This will be 1. And since I have a current source, so current value for I love 0 minus, in series I'll have a voltage source again. Right? So let me draw that. So at t greater than 0. So this is the voltage source. So capacitor in series with a voltage source. Remember, for a capacitor ऊपर प्लस होता है, नीचे माइनस, right? And the current is going upwards. So I'll have here this and a voltage source. Again minus to plus for right downward going current. And I have a current source. What are the values? 1.5. So this is 1. This is 0.5 s. This is 1. So 1 by s. So voltage source is what? Voltage value is 1. Right? So V of 0 by s is for capacitor. So 1 by s here. And it is L into I of 0. So 0.5 for inductor side. Next, what do you have to do? So this will be current which is given as I of t. So in Laplace domain it will be I of s. So next, just apply again what? KVL. Right? So let's start from here as usual. 1 by s minus 1 by s I of s minus 0.5 s I of s plus 0.5 minus I of s equal to 0. Right? So again all I of s are negative, so I'll take to the left hand side. In fact, right hand side, then I'll convert to left hand side. So I of s into 1 by s plus 1 plus 0.5 s equal to 1 by s plus 0.5. Remember, there is 1.5 here. So therefore I of s into What will this be? So this I can say is, I am skipping one step, so s plus 1 by s. So s plus 1 plus 0.5 s square upon s equal to, this will be 0.5 s plus 1 upon s. So therefore I of s equal to 0.5 s plus 1, ss will get cancelled, upon 0.5 s square plus s plus 1. So multiply by 2 because I want coefficient as 1. So s plus 2 upon s square plus 2s plus 2. Right? So I'll use this part. So I of s, what I've got, s plus 2 upon s square plus 2s plus 2. So we have to simplify this. So s plus 2 upon s square plus 2s plus 2. So again I want a perfect square here, right? So what I do, let's see the numerator later. So I divide this by 2, right? So what I get, s plus 1, make this s square. So s square plus 2s plus 1 I get, right? So here I'll have to add 1, right? So this is of the form s plus a the whole square plus omega square. Means I require what here, only s plus 1 to make the, take the inverse Laplace transform in terms of what, cos, right? So what will I get here? So I'll have to add 1 separately. So 1 of plus square plus 1 plus 1. So what will be I of t? So this is s plus s upon s square plus omega square, but shifted. So you multiply by e raised to minus t and cos. So e raised to minus t cos t plus this will be what? Instead of s plus 1 we have only 1. So e raised to minus t sin t amperes. Right? So the first and second lecture is very important for this. If you are not understanding this, means you have not seen the first and second lectures. So see that lecture, practice those properties, and then you will understand what I have done here. Okay. So let's take the last sum. So again the switch is closed at t equal to 0. So find currents I1 of t and I2 of t when initial current through inductor is 0 and voltage across capacitor is 4 volts. So this is already given, right? So we don't have to write the initial conditions. So we can directly start with at t greater than 0. So what will happen? Voltage source will be 10 by s. So switch will be closed. So this resistor will be there. This will be there. Current through inductor is 0. So no question of voltage source in series. Then I have 1 ohms capacitor, right? And then current is flowing downwards for capacitor and the value is given as 4 volts. So this will become 4 by s. This will be 1 by s. This will be 1 ohms. This will be I2 of s. This will be I1 of s. This will be 1 ohms, 1 ohms, and this will be s. I'll change the pen. So KVL to mesh 1, obviously we are seeing two loop currents. So 10 by s minus I1 of s minus of what? I can say this is what impedance together is s plus 1. So s plus 1 into I1 of s minus I2 of s equal to 0. Right? So collect the terms in I1 of s. Right? So what will you get? S plus 1 I of s minus I1 of s. In fact, we will get minus because this is minus, right? So what will I get? Minus of s plus 2 I1 of s. Then this will be plus. So plus s plus 1 I2 of s. So plus s plus 1 I2 of s. This will go here, so it will be minus 10 by s. Right, so I'll simplify it. So this will be plus and then minus, and s plus 2, s plus 1. So s plus 2 I1 of s minus of s plus 1 I2 of s equal to 10 by s. So this is equation number 1. So then KVL to mesh 2. So I'll start from here. So what will you get? Again you are going, current is going upwards now, so minus of s plus 1 I2 of s minus I1 of s, minus of s plus 1 I2 of s minus I1 of s. Then you come here, minus I2 of s minus 1 by s I2 of s minus 4 by s. So minus of, you can say 1 plus 1 by s I2 of s equal to 4 by s. I have skipped one step, right? So what will this be? I2 of s is only one term, so I'll write it will be plus, so s plus 1 times I1 of s s plus 1 times I1 of s minus of s plus 1 minus of, both are minus, right? So it will be minus of s plus 1 plus 1 plus 1 by s. I2 of s equal to 4 by s. So therefore s plus 1 I1 of s minus of s plus 2 plus 1 by s I2 of s equal to 4 by s, right? So therefore multiply by minus 1. If you want you can keep it like this. I am just multiplying by minus 1 into I2 of s equal to minus 4 by s. So this is equation number 2. So how to find I1 of s and I2 of s? You cannot use calci. So again, as we did in one of the previous lectures, what you will use? You will use Cramer's rule. So you mention by Cramer's rule. So what will be I1 of s? You worry of the numerator later, not require more space. So I1 of s equal to, right? So what will this be? Just determinant of the coefficients of I1 of s and I2 of s. So what is the coefficient of I1 of s? S plus 2 minus s plus 1, right? So that will come here. So s plus 2 minus of s plus 1. Then this is minus of s plus 1 and this will be plus s plus 2 plus 1 by s. So minus of s plus 1 s plus 2 plus 1 by s, right? Then what we are doing, we are finding I1 of s, right? So what we have done, we are keeping this column as it is. Since it is corresponding to 1, so we change the first column. So and what will be the first column? This coefficient. So 10 by s and minus 4 by s. So 10 by s minus 4 by s. So minus of s plus 1 s plus 2 plus 1 by s. So just cross multiply. So this will be 10 by s into s. So 10 plus 20 by s. So plus 10 by s square minus of s plus 1 into 4 by s. So minus 4. So minus of minus s plus 1 into 4 by s. So it will be plus. So minus. So don't worry about the minus sign. So 4 by s into s is 4. Then minus 4 by s. So minus 4 by s upon. So this will be s square plus 2s plus 1 plus 2s plus 4 plus 2 by s. Again minus in both. So don't worry about it. So minus s square minus s minus s minus 1. So therefore I1 of s equal to, so what will this be? So we see it is becoming quite complicated, right? So what you can do is just multiply these two and take LCM before multiplying, and let's see what happens. So you'll come to know why am I doing that. I'll take a new page for that. So I think it is visible. Yeah. So I1 of S equal to what it will be? 10 by S. As I said, you take LCM. So what it will be? S square plus 1 by S. Right? So if I take this, it will be S plus 1 by S plus 2. It is the same thing. So S square plus 1 upon S plus 2. So what will this be? S square plus 1 plus 2S upon S. So if you see S square plus 2S plus 1 means S plus 1 the whole square upon S. Right? So we are getting something better. So it is S plus 1 the whole square. Sorry. So I1 of S is 10 by S into S plus 1 the whole square upon S minus S plus 1 into 4 by S. S plus 1 into 4 by S upon. Similarly here, so this is S plus 2 plus 1 by S same. So S plus 2 into S plus 1 the whole square by S minus S plus 1 the whole square. So you are getting something same. So this indicates you are, it will be simpler to perform the Laplace inverse Laplace transform. So therefore, what will be I1 of S? So 10 by S square into S plus 1 the whole square minus, this will be as it is, S plus 1 times 4 by S upon S plus 2 into S plus 1 the whole square upon S minus S plus 1 the whole square. Right? So if you see S plus 1, at least 1 will get cancelled. Right? So therefore, I1 of S equal to 10 by S square into S plus 1 minus 4 by S upon S plus 1 into S plus 2 upon S minus of S plus 1. Right? So if you solve this, what will you get? So 10S plus 1, 10S plus 10 upon S square minus 4 by S. I'll take a new page. So I1 of S equal to 10S plus 10 upon S square minus 4 upon S upon S square plus 2S, 3S it will become, plus 2 upon S minus S minus 1. So take LCM again here. So 10S square plus 10S minus 4S square upon, this will be S cube upon S square plus 3S plus 2 minus S square minus S upon S. Right? So this will be 6S square plus 10 upon S cube. This will become into S upon S square gets cancelled. So 2S plus 2. Right? So this will be equal to 6S square plus 10 upon S square times 2 common, so S plus 1. Right? So what will you get? This is 10S, right? So this will be 10S, 10S. So SS will get cancelled. So 6S plus 10 upon 2S times S plus 1. So therefore, I1 of S equal to, divide by 2. So 3S plus 5, because you want coefficient of S to be 1. S times S plus 1. Right? So how to solve this? So I'll write again here. So I1 of S equal to 3S plus 5 upon S times S plus 1. See, whenever you get this type, it is what? Partial fraction. Right? So what we do? Therefore, I1 of S, first we write by partial fraction expansion. So I1 of S equal to, so what we do? Take S equal to 0. Substitute everywhere except this s. So this s is as it is, so this will be 1. So 3 plus 5 is 8. Right? S is 0, sorry. So this will be 5. I took it as 1. So plus, then take s is minus 1. Keep this as it is. So 5 minus 3, so 2. Right? So therefore, I1 of s equal to 5 by s minus 2 upon s plus 1. So therefore, taking inverse Laplace transform. So I1 of s equal to, what will this be? 5 only, minus 2 e raised to minus t ampere t greater than 0. What mistake I have made? This should be I1 of t. Similarly, you can find I2 of t. So that will be homework. Okay. So you can find I2 of t.